What if tomorrow scientists announced they had found a doorway to a parallel universe? What it means for everything we know? This is not pure science fiction. Several serious branches of physics predict that parallel universes are not just possible, they may be inevitable. Here's what would actually happen and what the science says, and why the implications are more mind bending than any story ever written. The first serious scientific case for parallel universe comes from quantum mechanics, especially the many world interpretation. Every time a quantum event occurs, a particle spinning up or down, decaying or not, the universe may split into two separate branches. In one branch, the particle spins up, in another, it spins down. Both outcomes are equally real, happening in different universes. This was proposed by physicist Hugh Everest in 1957. He believed the wave function never collapses. It keeps branching forever. If many world is correct, the number of parallel universes created every second is incomprehensibly large. One for every quantum event everywhere. You have counterparts in those universes who made different choices, lived different lives, and some who may not be lived at all. String theory proposes that reality has more than 4 dimensions, perhaps 10 or 11, with the extra one curled too small to see. Other universes in string theory does not exist in the same space as ours. They exist on separate membranes like parallel sheets stacked in hyperspace. These membranes or branches can interact. Some physicists believe the Big Bang itself was caused by two branches colliding. If branches can collide and spark universes, then our universe may be just one of the collapses, countless others produced by same process. Landscape predicts something like 10 to the power of 500 different possible universes, each with slightly different laws of physics. Some of those universes might have heavy electrons, strong nuclear forces, or no stable atoms, making life as we know it impossible. A portal to a parallel universe, if one could exist, would most likely be a wormhole, a tunnel through the fabric of spacetime. Einstein and Rosen derived wormholes mathematically in 1935. They are not forbidden by general relativity, but they are extraordinarily fragile. A natural wormhole would collapse almost instantly unless held open by exotic matter with negative energy density. Negative energy is real, demonstrated in seismic effect, where quantum fields between two metal plates create a measurable negative energy pressure. Whether negative energy could ever be produced in sufficient quantities to stabilize a wormhole is an open question. The math does not rule it out. If a portal existed, it might look like a perfect sphere of distorted light, a shimmering window into another reality, hovering in space. Step through, and what would you find? If the universe is quantum branches from ours, it could look almost identical at first. The laws of physics might be the same: gravity, electromagnetism, the speed of light, all unchanged. Just the history would be different. Some quantum event billions of years ago went differently, cascading through cosmic history into a world that diverged from ours. Earth might exist, the sun might shine, but civilizations, species, and the entire continents might have taken completely different paths. You might find a version of Earth where the asteroid that killed the dinosaurs missed, and intelligent dinosaurs evolved instead of mammals. Or a version where the Roman Empire never fell, where your country does not exist, where you were never born. But parallel universes does not have to share our physics. If the portal connects to a string theory branch, all bets are off. The fine structure constant governing how electrons and photons interact could be different, making chemistry impossible or wildly unlike anything we know. A universe with slightly stronger nuclear forces would have collapses in its first seconds. One with weaker forces would have no stars. We might step through to find only empty space, a universe in a different vacuum state where our matter does not exist. Or we might find something with no name at all, structures and phenomena our physics has no framework to describe or predict. The universe next door could be the most alien environment imaginable. Even if it's only one quantum event removed from our own, assuming the portal is stable, and the crossing itself might be instantaneous. Wormhole traversal in theory happens at normal speeds. The biggest unknown is tidal forces, differences in gravitational pull across the length of your body that could stretch you apart. A traversable wormhole would need to be large enough that tidal forces across the human body are survivable. Size matters enormously. Quantum decoherence might also be a problem. Your body's quantum state might not translate cleanly through the apology of the portal. And there is the Fowell paradox. Some physics believe the interior of any such structure would be a wall of lethal high energy radiation. The honest answer, we don't know if traversal is survivable. The theory is incomplete and the stakes of testing it are absolute. Scientists have not found a portal, but several experiments are already looking for signatures of parallel universes without requiring one. The Large Hadron Collider has searched for microscopic black holes that would indicate extra dimensions, gateways to branch world universe. It has not found them yet, but the next run at higher energies will probe deeper into scales where extra dimension might first appear. In 2022, quantum computing experiments simulated systems that behaved as if information was traversing a wormhole-like connection between two regions. This was not a real wormhole, but it demonstrated that the physics underlying wormhole is real and experimentally accessible today. Some cosmologists are searching the cosmic microwave background for cold spots or anomalies that could be imprints of parallel universe collisions. Compression enough exotic matter to hold a wormhole open would require technology millions of years beyond anything we have today. But physics does not explicitly forbid it. Alcubierre warp drives and traversable wormholes are all theoretically consistent with general relativity. Some physicists believe that advanced civilizations, if they exist elsewhere in the universe, may have already solved this problem. If the universe is old enough and large enough, the first civilization to discover wormhole engineering had billions of years head start. We might not be looking for a portal built by the nature. We might be looking for one built by someone else entirely. The discovery of a portal would be the single most transformative event in human history, making every previous discovery seem trivial. It would confirm that we are not alone in the space of possible realities, that existence is far larger than our universe. It would raise questions we do not have the philosophy for, let alone the physics, about identity, consciousness, and what it means to exist. Every version of you in every branching universe made different choices. Some thrived, some did not make it this far. And somewhere in the vast landscape of parallel realities, every version of this moment is playing out differently right now. The portal may never be bound, but the search for it is clearly changing how we think about reality and our place in the cosmos. The most staggering truth: the question is not just scientific, it's the deepest question about what is real and what exists. From quantum branching to brain collisions, the science says other realities are not impossible, they may be inevitable. If this opened a door in your mind, subscribe and share. Comment which universe you would want to visit. See you on other side.